Okay, so part of what we need to be able to do is we need to be able to understand what exponential functions look like. For example, we have exponential and logarithmic functions, and they have a relationship, and we're going to discuss that relationship tomorrow. But first, an exponential function is different than your normal polynomial. So you're going to go to the very last page. That's where we are. And instead of, say, y equals x to the third, we're going to talk about y equals 3 to the x. So an exponential function is something of the form y equals a to the x. We may change what a is. But there's some important characteristics of that function that we need to talk about, and it's going to help you understand how to graph logarithms. So we have y equals 3 to the x. If I plug in 0 for x, what is the y value? What is anything to the 0 power? It is 1. Why? If you take x to the fifth, divide by x to the fifth, anything divided by itself is. And if you subtract the exponents, you get x to the. So we know that anything to the 0 power is 1. See that? Okay. So that's your argument to understand that piece. As we move forward, we want to understand what this graph looks like. We know it goes through 0, 1, but I'm going to take out my calculator. You can take it out with me if you'd like. I type in 3 to the x. And I'm going to go to my table set. I'm going to make sure that my independent variable is set to ask. If I go to my table and I delete the current entries that I have, and instead I type in, say, 3 to the 0, you can see that I get 1. But if I type in 2, what is 3 to the second power? Yeah, as I type in a few values, you can see the pattern that's developing here. What's happening to the y values? At a ridiculously fast rate, right? I mean, you look at how fast the x values are increasing. The y values are increasing at a much greater rate, right? Okay, it's kind of like the bacteria on your phone, right? You have a couple bacteria and produces a couple more. Well, all of a sudden becomes a larger group that's repopulating than even a larger, like rabbits, right? All they do is eat, sleep, and repopulate, right? It's a good deal to be a rabbit. And, you got a couple of them, you're not going to get that many more. But you got 100, all of a sudden, wow, you're going to have a lot of rabbits, right? Yeah. So you can see what's happening. And so as x gets larger, the y values become ridiculously large. Let's watch what happens as the y values get smaller, say, or the x values get smaller. -1, -2, -3, -4, -5, -6. If you take 3 to the -1 power, what is 3 to the -1 power? What does that mean to take 1/3? You flip it, right? And 3 to the -2 power is 1 over 3 squared, or 1 over 9. So what's happening to the y values now? Getting ridiculously small. In fact, they're getting very close to what number? 0. Yeah, in fact, if you type in, say, -20, you get 3 times 10 to the -10th power. So that's a 3 with 9 zeros in front of it. It's getting very close to 0, but it won't ever cross over. So we know that the graph looks like this. It gets very close to 0, and it spikes up. And it has what we call a horizontal asymptote, something that you're very used to now. And that horizontal asymptote is y is equal to 0. What do you notice about the domain of this function? Yep, all real numbers. And the range, y greater than 0. Yep. And it has an asymptote value of y is equal to 0, and it passes to 0.01. And usually that's really enough information to try to generate a graph. Now, if we look at a different situation, let's suppose that the a value, what we're taking to the x power, is between 0 and 1. So I'll try y is equal to 1 over 3 to the x. Well, if we type that in, you can see that we're going to generate some different values. Parentheses 1 divided by 3 raised to the x power. So as I go to my table, I'm going to get rid of these values, and I'm going to go to typing in 1 We get 1/3. If you type in 0, you can see you're going to get 1, 2, 3, 4, 5. This time as I type in larger x values, what's happening to the y values? They're becoming ridiculously small. Yeah, when I plug in 0, I still get 1. It goes through that point. If I do the opposite, if I go, say, -1, -2, -3, -4, -5, -6, what's happening to the values now? They're getting bigger. In fact, this graph looks similar, but it's slightly different. Now, I'm going to try to show you something that will make your brain go, aha, but we'll see what happens, all right? So, um, another way to rewrite 1/3 is y is equal to 3 to the -1 to the x power. Would you agree that these two expressions are the same? Okay, and if you take a power to a power, what do? You multiply, so y is equal to 3 to the -x. So this is the graph of y equals 3 to the -x, and this is the graph of y equals 3 to the x. The negative is on the inside. The inside creates what? A horizontal flip. A few people whispered it. So you can see that that's the relationship between when the a value is less than 1 and when it's greater than 1. Just that it creates that negative exponent, which is a horizontal flip. Now, if you had a number such as e is what we represent by continually compounding something. So, for example, continuous growth. Uh, money. Money in my bank account does not grow continuously, okay? It grows, say, annually. Like annually, I get a return on my investment. Maybe quarterly. So every so often, you say, that's when I'm going to get some interest. Bacteria, on the other hand, that doesn't just decide, oh, well, it's Saturday, I guess I'll grow some more. It just grows all the time, right? Like mold on a bread, right? It's just going to so like I say, no mold on Sundays. It doesn't work like that. It just continues to grow. E is the base that we use to represent continuous growth. So a lot of people are like, what is E? E is similar to pi in that it's a number. It goes on forever. It never repeats itself. Okay? But it's different. Instead of 3.1, it's 2.7. And I can show you how they come up with 2.7, but that's going to be at a little bit later time. And so the graph of E, because it's greater than 1, is going to look very similar to the exponential graph, y equals e to the x. And you have an e button on your calculator. You can, it's right by the natural logarithm button right here. Well, there's two of them, so you're right. You could go y equals second e to the x, or you could go second natural logarithm. It says e to the what power x. So you can either use it as a number or as a function. So, okay. So you have those options. However you graph them, they're going to be the same, obviously, and you can see that it looks like what we have. Your calculator has a very difficult time graphing this against the y-axis because, or against the x-axis because it's so small. If you wanted to take off your axes, which I showed you how to do at one point, then you can see that, the graph is a little bit more viewable at this time. So, okay, if it's e to the negative x, that would be the same as y equals 1 over e to the x. And so it starts up and it finishes down in that situation. So if you see e, don't freak out. It's not a big deal. It's just a number. Bigger than 2, less than 3. We all good? Let's try some examples. Flip to the very front of your notes. These are 4 sections that we are going to cover. We're going to cover exponential functions, logarithmic properties, and then solving the logarithmic and exponential functions. We will also do a little bit on, how do you want to say it? We're going to do a little bit on a regression and word problems. So 4 to the x. Base is greater than 1. What point is it going to go through? It's going to go through 0, 1. Because the base is greater than 1, is it going to start down and finish up or start up and finish down? Start down and finish up. Now the directions say to state the domain and the range and the asymptote. Y equals 0. Yep. The 4, I will talk about what the 4 has to do with the problem when we get to letter C. Okay. The range is going to be y is greater than 0, and domain is all real numbers. How will B look different than A? Okay. It'll start up and it'll finish down. Because it is truly y equals 4 to the negative x. That's the graph. And so it creates that horizontal flip. So again, I have a domain of all real numbers. I have a range of y greater than 0. And I have an asymptote, again, of y is equal to 0. Now, will letter C look like letter A or letter B? It will look like letter A. And so, when we draw it, we really don't see any difference. And so Maddie's question comes up, what is the difference between those two functions? Does anybody know how they would be different? Yeah, so if you plug in a value for x, say you plug in 1, then the y value will be 4. If you plug in a 2 value for x, the y value would be 16. Plug in 3, and you're going to get 64. Whereas for this graph, you plug in 1, you get 2. Plug in 2, you get 4. Plug in 3, you get 8. So this one, the letter A is increasing at a much greater rate than letter C is. But it's very difficult to show that. So we're not very concerned about you trying to show that as you graph it. What we really want is the general shape, the domain, the range, and the asymptote. Yes, in calculus, we start to talk about how fast they change rates. However, we're not really concerned about showing that graphically so much. I can't think of a time where you're really like, let's show the difference between two. How about this? If I drew two graphs, and I said, one of these is y equals 4 to the x, and one is y equals 2 to the x, hopefully you can figure out that then this one's 2 to the x. But, it just doesn't get as big as fast. So, all right. So how is D different? It's got a negative. Is the negative on the outside or the inside? It's on the outside. So what kind of flip does that create? A vertical flip. So you remember what it used to look like? It used to have a, is the vertical flip going to change the asymptote at all? It's not going to change the asymptote, but it used to pass through the point 0, 1. So now it's going to pass through the point 0, negative 1. And if that bothers you, just understand if you plug in 0, you get 8 to the 0, which is 1 times the negative is negative 1. So you do get that coordinate. Okay, and it creates this vertical flip like so. Domain is still range, and the asymptote, y is equal to 0. You can draw. You're excellent in drawing. I believe in you. I believe in your Colorado shirt. The asymptote is y equals 0. Y less than 0. Yes. Okay. Go ahead. How is E different? Yes, Braden. What is that 0, negative 3? The y-intercept? Okay, excellent. So why is it at 0, negative 3? Can you tell me? Why are you subtracting that much? What tells us to do that? The minus 4. So the minus 4 is on the outside, and therefore it creates a vertical shift. So everything's going to be shifted down 4 units. So instead of having a horizontal asymptote at y equals 0, I'm going to shift that horizontal asymptote down 4 units to be through y is equal to negative 4. So we have our asymptote of y is equal to negative 4. Now, it used to pass through 0, 1. B. Rodden said that it's going to pass through 0, negative 3, because it shifted down 4 units. I think that that's an excellent thought, and I would agree with him. There's no negative, so it's not going to flip vertically or horizontally. And so, again, I have a domain of all real numbers, and I have a range of the range. You know, I just take that horizontal line and I start dragging it. You know, when does the graph? Whoop, when does this start to intersect the graph? At 4 or negative 4, it doesn't intersect the graph. But when I get any spot above 4, that's going to start to intersect. What are the 3 things I need to be concerned about with letter F? Travis, what does the x minus 2 do? It is on the inside, so it's going to be a shift to the right 2. Will that change the asymptote? Moving it right to left, does that change the asymptote? No. But there's a vertical shift. Does that change the asymptote? Yeah. So this asymptote is going to be shifted up 1 unit. There's no other asymptote, just the one. And it's going to be shifted to the right 2 units. So if I think about that coordinate, that coordinate used to pass through 0, 1. Well, if it's shifted up 2 or up 1 into the right 2, now it's going to go through 2, 2. It used to go through 0, 1, and now it's shifted up 1 and right 2. Okay, so now this is the coordinate it's going to go through. And you tell me, is it going to start down and finish up or start up and finish down? Start up and finish down. Because you have a 2/3, that's less than 1, so it's going to start up and finish down. Just like letter B. Yes. Yeah. We flip. Okay, last 4 problems here. Find the exponential function that passes through the following points. Instead of the, we're going to say and, because there's an infinite number of answers here. You notice that for each example here, all these exponential functions pass through what point? They all pass through 0, 1. So I'm looking for something of the form y equals a to the x. So it could be, say, y equals 5 to the x. It could be y equals 2 to the x. It could be y equals 2 over 9 to the x power. We want to know what that a value is that satisfies these coordinates. So I have to figure out what it is. So y is equal to a to the x. My y value is 25, and my x value is 2. So what number do you square to get 25? You square 5. And so therefore, a is 5. Now, if you write a is 5 on your test, it don't give you credit because it says find the exponential function. That's not an exponential function. The exponential function is y equals 5 to the x power. That's what I want to see. The next one, y equals a to the x. What is my y value? 2/3 equals some number a to the negative 1 power. What number would you take to the negative 1 power to get 2/3? You would take 3/2. Yes, you would take 3/2. So therefore, a is 3/2. Y equals 3 over 2 to the x power. What I'd like you to do is try C and D on your own. Some of you look astonished when you come up with the right answer. And if I looked astonished when you came up with the right answer, you'd you'd feel bad. But so you should be astonished. You're very smart people. I expect that you would have the right answer the majority of the time. Heck, you guys just took a test where the first quartile was 90%. Teachers should get raises for that. I mean, really. Yeah, even with no calculator, look at that. Did you get y is equal to 2 to the x for C? What number would you take to the fourth power to get 10,000? 10. So what number would you take to the fourth power to get 1 over 10,000? 1/10. So therefore, you have y is equal to 1 over 10 to the x power. Some people will choose to write it differently. Either one is acceptable. Free country, do what we want. Here's your assignment.